Today we're going to be getting an introduction to what a limit is, its concept, and what it looks like intuitively. Limits are especially important future on in calculus by defining the derivative and by evaluating integrals. For starters, what is a limit? What is their concept and why do we need to learn them? For starters, the limit, which is spelled Limit, is the value that x approaches when it infinitely gets close to it. For example, we have the limit as x approaches 2 for f of x. But for f of x, notice how f of 2 does not exist. So NA. And why doesn't f of 2 exist? The reason why is because when you apply 2, the denominator will result in 0. And remember, the denominator can never be 0. So let us just evaluate what f of 2 will look like if we don't redefine f of x. When f is defined to be when x is equal to 2, this will result in 2 minus 2 in the denominator and 2 minus 2 times 2 minus 1 in the numerator. This will be equal to, if we simplify, 2 minus 2 will be 0, and 0 times 1 will be 0. And you see we got 0 divided by 0. What is 0 divided by 0? That is undefined. But we know that if we simply rearrange f of x, we'll simply find what f of x is when x is equal to 2. To do this, if I move myself right, this will be equal to, if we divide x minus 2 on both sides, to be f of x is equal to x minus 1. And when f of x is defined to be x minus 1, f of 2 will have a quantity. That will be 2 minus 1, which will be 1. So when we redefine this function f of x, it will have a value when x is equal to 2, which is 2 comma 1. But in our original function, f of x is equal to x minus 2 times x minus 1 divided by x minus 2, x will not have a defined point when x is equal to 2 because the denominator will be 0. And we all know that the denominator can never be 0. So how are we supposed to understand what a limit is if the function when x is equal to that specific quantity does not exist? Well, here is the big difference between a limit and a point on a function. Whether the point for this function exists, which is 2 comma 1, exists or not, we don't care about it at all. All we care about is when x infinitely gets close to 2. Important. When x infinitely, it will never quite reach x is equal to 2, but when it infinitely gets close to 2, what will be the value of y? What will be its value when x infinitely gets close to 2? Intuitively, if we visualize it on the graph, x will infinitely get closer from the left hand side. Same thing, get infinitely closer from the right hand side. And as it infinitely gets closer, what will be the y quantity for f of x? Well, if we look from our graph, it's simply just 1, because if we draw a vertical line over, this point will be 2 comma 1. So when x infinitely gets close to 2, it will be equal to 1. And how do we evaluate and make sure that what we just concluded based on visually will be correct? Well, that brings us here to limit notation and how we represent a limit. To represent a limit, we are abbreviating the limit to simply LIM. So right here you see we have the limit, LIM, representing the limit, with x approaches 2 represented through this arrow. This arrow means it infinitely gets close to when it approaches some value. In this specific case, x will infinitely get close to or approach when x is equal to 2 of this function. This is just telling us what is the limit of this function, f of x, when x goes to 2. When x approaches 2, what will be the limit of this function, f of x? To find out, let us rewrite our function. Our function is just x minus 2 times x minus 1 divided by x minus 2. But notice how we have to redefine this function in order to find our limit. This will be equal to the limit when x approaches 2, when we divide x minus 2 in both the numerator and denominator, x minus 1. And to evaluate this limit, we simply apply the value x approaches into our function that we want to find the limit for. So this will be equal to, once substituted, 2 minus 1, which will equal the value of 1. Therefore, when x infinitely gets close to 2, for this function of x minus 2 times x minus 1 divided by x minus 2, the value of this limit will be x, or y, is equal to 1. And you can see here visually that when we approach 2 from the left hand side and approach 2 from the right hand side, it will approach x is equal to 1. And that you might be wondering why I said that this limit exists. And what makes a limit to be defined? Well, a limit is defined when the left limit, which is represented by when x approaches some value with a negative symbol on top of f of x, is equal to the right limit when x approaches n from the left hand side of f of x. This will result in the limit of x approaches n of f of x. And what is a left limit exactly? And what does this notation really mean? So likewise, the lim stands for limit. We want to find the limit of what? Of this function, f of x. But for what limit? When x approaches n from the left-hand side, represented by this negative symbol on top. And how would it look like? And what is a left limit? Well, going back to this example, the left limit will be when x approaches a certain variable from the left-hand side, or the negative side. So coming from negative infinity, this red color, it will go, trying to approach it from the left-hand side. That is what it's called, a left limit. Then we move on to the right limit. What is a right limit? Well, a right limit represented by the same notation except with a positive symbol right here to represent it, direction approaching n from the right hand side of f of x to look like going from the right hand side and infinitely getting close to x is equal to some variable of n. In this specific example, x will approach 2. So how can we be sure that this exists, that this limit is indeed correct? Well, we can evaluate the limit first of all from visually in the graph. When x approaches 2 from the left hand side is this red arrow. This red arrow is infinitely getting closer to the point of 2, 1. And it certainly does look like it is approaching the y value of 1 when x goes to 2. And likewise, when it goes to 2 from the right hand side, from this orange arrow right here, it will get close from the right hand side, and it will certainly look like it's approaching the point of 2, 1, the y value of 1 when x infinitely gets close to 2 from the right hand side. Therefore, if the value that the left limit approaches is equal to the value the right limit approaches, then the limit for that specific quantity when x approaches n will exist. In this case, what is that limit? That limit will be 1. So not only did we go over what a limit is conceptually, we also gone over 2 ways to evaluate limits, visually and substituting them, which is, in this example, x goes to 2, we substitute 2 into our function. And this will be the step in our long course of calculus. And the first step to understand limit functions, or rather the limit of functions, limit properties, and how to evaluate them, and much more complex functions. This will be the end of our introduction. I hope you have learned something new about limits and have understood what they are.